going to take you a little bit beyond the algorithm. We've been talking about AI for future and AI for good. And I would just like us to think a little bit beyond the actual algorithm and the systems themselves to how we deploy them in the real world. And I'm going to use the healthcare as a context. And I'm particularly interested in addressing the threat of skills fade in situations such as our doctors and nurses going forward. So in 5 minutes. What started me thinking about this was this article in Nature, which was one of the classic AI can predict diseases better than, or can diagnose better than doctors headlines that we often see. And this, lo and behold, was one about childhood diseases, and it had all the claims. And I was intrigued, so I read a little bit deeper and looked at the data. Now, bearing in mind the authors were very honest about this, and you can see in the legend that they do flag this issue up that I'm going to raise with you. But it does predict the diseases better than doctors, but junior doctors. So the first two physician groups here are junior doctors, and you can see that the AI system predicts better than the junior doctors, but it does not predict better than the remaining three groups, which are senior physicians. And quite significantly, if you look at one doctor here, there's got 0.972. It's really significantly higher than the equivalent AI solution. And so it got me to thinking, right, well, that's very good. It can be better than junior doctors. How will you deploy such a model? Are you going to use it to train the doctors, or are the doctors going to refer to it? And how will that impact on junior doctors going forward? Will they ever get to the same skill level as the senior doctors, or are we risking capping the degree of their knowledge? So how we deploy these and then how we use them, I felt was really, really important. And another article that really addressed this issue very, very well was one, it was at Google Health and working with some big research looking at screening for breast cancer, and they developed a deep learning system that could predict tumours within breast cancer. And again, we had initial sort of saying that it predicted the potential of breast cancer better than a single radiologist. But they were a very interesting bit of research because they compared US and the UK. And in the US, only a single radiologist often views scans to make the diagnosis. Within the UK, a minimum of 2 radiologists will always view a scan before diagnosis. And what they found was, yes, the AI was better than a single radiologist, but it was not better than the 2-view process that was being deployed within the UK. So again, this raises the question of how would it be deployed? Are we at risk of maybe under the pressures of funding and managers wanting to maintain budgets, that the idea of a reasonably good AI system might replace radiologists when in fact it actually should act as an adjunct? And how then does the radiologist make that decision? Do they make their own decision first and then check with the AI system? And if there is a disagreement, then go to a second opinion? Or do they look at the AI system first, in which case can it influence the decision making? And there's quite a lot of research showing that people can default to the AI system, and this human in the loop scenario that the GDPR includes often is not really correct, and you end up with a human in the loophole. They're just a tick box interface between the AI and the outcome and the decision. So we need to ensure that the practices we employ are very, very carefully that the AI is in the loop, not the human is in the loop. And again, some other issues about explainability. Earlier on, we heard about key issues within AI ethics to do with bias, security, privacy, explainability. And here's some really good research on how an AI system that was designed to detect pneumonia, there's been similar ones to do with hip fractures, actually spent an awful lot of its time making its diagnosis based on the type of scanner it was used and the hospital processes that were being developed. So if a portable scanner was used, the AI was making an assumption that the person was more likely to have whatever ailment that the scanner was being, the image detection system was being used to detect. So that leads you to think about, well, if you deploy this system within your hospital setting, and maybe you use a different process, maybe you don't have portable scanners, or maybe you change the type of portable scanner that you use. If you don't know how your system is making its decision and your operational procedures change, that could significantly affect the accuracy of your AI system. And therefore, the importance of ongoing evaluation is really, really key. And the main part of the talk, which I'm very short of time, so I'll be as quick as I can, was the issues of skills fade. This is well known within the aviation industry, that who has been dealing with automation for a very, very long period of time. And there have been safety notices put out by the Federal Aviation Authority in the US, and in the UK, the Civil Aviation Authority have also highlighted this, that dependence upon autopilots and systems such as fly-by-wire is de-skilling pilots, and they are making the suggestions that where possible, manual flying should take place, because AI systems are fine when everything is going as expected, but when there is a crisis or an unusual event, they are not so good. And this is when you want the human to step in and override. But with reliance on automation, those skills and that training actually gets minimized, and that override in the AI causes catastrophic problems. And within the aviation industry, it has actually caused crashes. And the classic example where somebody with high manual skills was very valuable was Sully, when he landed Captain Sullenberger, when he landed the jet on the Hudson River. He has very sort of doubtful views about automation, and his skill level was very high. So it's about trying to set up you're balancing your processes so you can monitor for that type of skills fade as well. And within the health sector, using surgeons for VR, for example, and all of these other systems can impact. And again, with predictive diagnostic algorithms, you can imagine how that cognitive skills as well as manual skills can begin to fade over time. So this way that you deploy your systems is really important. And really quickly, bias and de-skilling. There is naturally bias within these systems. So for VR, for example, it has an increased tendency for motion sickness in female surgeons than it does in male surgeons. And so you can imagine that system was deployed within a hospital. It can have effects on the outcomes of those surgeons' careers, and also obviously on patients. If you've got a surgeon that's dealing with less than optimal conditions, voice recognition systems for noting down emergency room notes, less able to recognize female notes and more likely to have critical errors than male written notes. So again, how does that impact on skills? So I will leave you very quickly with a quote. "The knowledge is not lost. It lives on in the few remaining specialists and researchers and in a database, but it is no longer being added to." So I'm not anti-automation and anti-AI, but how we deploy it and how we monitor for skills fade and make sure we work together is very, very important. And I hope I probably didn't stick to 5 minutes, but there you go. Thank you for listening.